Hey everyone, and welcome. Today, we're going to crack a mathematical code. You know, one of those things that looks super complex, but is actually surprisingly simple once you know the secret. This is a concept that really unlocks doors in everything from algebra all the way up to calculus. So let's get started. All right, let's dive right in with the puzzle itself. Now, I know it might look a little intimidating right now, but I promise by the end of this, you'll see it as just a simple set of instructions.
So, you see this thing? What on earth is it actually asking us to do? That little fractional exponent up there, the 3/2, that is the heart of the code. And to decipher it, we're going to need to find two keys.
Now here's the cool part. These keys are concepts you have almost definitely seen before. We're talking about powers and roots.
Okay, so our first key is a power, an exponent. It's really just a shorthand, a quick way to write, multiply this thing by itself a bunch of times. So x cubed, that's just x times x times x. Simple enough, right?
Our second key is the radical, or a root, and it's basically the exact opposite of a power. The cube root of 8 is asking, hey, what number, when you multiply it by itself 3 times, gives you 8? And the answer, of course, is 2. So you can think of it like this. Powers build numbers up, and roots break them back down. Okay, so we have our two keys. Now, for the fun part. Let's see how they actually fit together to unlock what that fraction really means. And here it is. This is the big reveal. These two notations, they look pretty different, but they are telling you to do the exact same thing. A rational exponent isn't some brand new, scary math operation. Nope, it's just a slicker, more compact way to write down the instructions for doing both a power and a root at the same time. So if there's one thing you remember from all of this, let it be this. Power over root. The number on top of the fraction, that's your power. The number on the bottom, that's your root. Always, power on top, root on the bottom.
And hey, if you're worried you might forget which is which, here's an awesome way to remember it, courtesy of Swarthmore College. Just think of a tree. Where are a tree's roots? They're always at the bottom, right? Same thing here. The root is always the bottom number of that fraction. It's a great little mental trick that makes it pretty much impossible to forget.
Okay, so now that we've totally cracked the code, let's start building our toolkit. We need to know the rules so we can actually use this stuff to simplify expressions. But first, a quick warning. This is a super common mistake, so listen up. Just because we're playing with these new fractional exponents doesn't mean we can just throw the old rules of algebra out the window. You still can't distribute an exponent over addition or subtraction. It's a classic trap, so definitely keep an eye out for it.
Now for the good news. All those exponent rules you probably already have memorized, the product rule, the quotient rule, the power rule, they all work the exact same way with fractions. You just add, subtract, or multiply the fractions up there in the exponent. No new rules to learn.
All right, time to go back to our original puzzle and see this thing in action. First, as you can see in step 1, we distribute that 3/2 exponent to both parts inside the parentheses. So let's tackle the 64 first. Remember, root on the bottom, so the 2 on the bottom means we take the square root of 64, which is 8. Easy. Next, in step 3, we apply the power from the top. 8 to the power of 3 is 512. Okay, the number part is done. Now for the variable. For step 4, we use the power rule and just multiply those exponents. So, 4 times 3/2 gives us 6. And for the grand finale in step 5, we just put them back together. The code is cracked. 512m to the 6th. Pretty cool, right? Now that you can simplify expressions like a pro, let's level up. We can use this exact same logic to solve equations that have these fractional exponents. So here's the game plan, and it's pretty much always these 3 steps. First, you've got to get the term with the rational exponent all by itself on one side of the equation. Isolate it. Second, and this is the magic move, you raise both sides of the equation to the reciprocal power. This cancels out the exponent on your variable. Then, you just solve for what's left. Let's walk through this example. Following our game plan, we first isolate that term with the exponent by subtracting 310 and then dividing by 2. Boom, it's isolated. Now for that magic move, we raise both sides to the reciprocal power, which is 5/2. On the left side, the exponents cancel out. Poof, which is exactly what we wanted. On the right, we just do the math. The 2 on the bottom means the square root of 9, which is plus or minus 3. And then we raise that to the 5th power. A little more algebra from there, and we get our 2 final solutions. But hold on, we are not quite done. With these kinds of problems, there is one last absolutely critical step you cannot forget. Seriously, it's a final twist that can change your whole answer.
You must always check your answers. You have to plug them back into the original equation to see if they actually work. See, the solving process can sometimes create what's called an extraneous solution. It's like a fake answer. It looks correct, but it doesn't actually work in the original problem. In this case, if we plug -3 back in, we find out the equation isn't true, so we have to toss it out. It's extraneous, and the only real answer is x equals 5.
So there you have it. You've cracked the code. That intimidating fractional exponent is just a compact, elegant set of instructions. Power over root is just a way to combine two familiar ideas into one.
And that leaves us with a final thought. We've seen that rational exponents are basically just radicals in a different outfit. So why do mathematicians, especially in fields like calculus, almost always prefer using x to the 1/2 instead of the square root of x? What's the advantage? What does this power over root shorthand give them? Something that you want. Thanks for watching.